Welcome to Tech Girl Kannada YouTube channel. Basics of networking and emergence of IoT. Basics of networking introduction, network types, layered network models, emergence of IoT, introduction, evolution of IoT, enabling IoT, and the complex interdependence of technologies, IoT networking components. Introduction. A collective network of connected devices and the technology that facilitates the communication between devices and the cloud, as well as between the devices themselves. Or the definition is computer networking refers to the linking of computers and communication network devices, also referred to as hosts, which interconnect through a network that can exchange data and share resources with each other. Some examples of IoT devices includes smart home devices such as thermostats, lighting systems, and security systems, wearables such as fitness trackers and smartwatches, healthcare devices such as patient monitoring system, wearable medical devices, industrial systems such as predictive maintenance systems, supply chain management, transportation systems such as connected cars and autonomous vehicles. The main network components are computers, channels, interface, or connecting devices, software. Computers, clients or service, channels, wired or wireless, interface or connecting devices, router, switch, etc. The software, protocols, system software, application software, etc. And here you can see the diagram. Computer network components, that is switch, hub, NIC, server, client, modem, cables, router. Now we get into the network types. Computer networks are classified according to various parameters, according to based on type of connection, physical topology, reach of the network. Let us see one by one types. Connection types. Depending on the way of a host communicates with other hosts, computer networks are of two types: point to point to multipoint. Point to point connections are used to establish direct connections between two hosts. These networks were designed to work over duplex links and are functioned for both synchronous as well as asynchronous systems. Point to point connection find usage for specific purposes such as in optical networks. Point to point host A to host B, point to point link host C to host D, point to point. Then, what are the advantages of this point to point? It is faster and highly reliable than other types of connections since there is a direct connection. No need for a network operating system, does not need an expensive server as individual workstations are used to access the files. No need for any dedicated network technicians because each user sets their permissions. Disadvantages: the biggest drawback is that it only be used for small areas where computers are in close proximity. You cannot back up files and folders centrally. Point to multipoint. In a point to multipoint connection, more than two hosts share the same link. Point to multipoint connection find popular using wireless networks and IP telephony. The channel is shared between the various hosts, either spatially or temporally. One common scheme of spatial sharing of the channel is frequency. division multiple access FDMA. Frequency division multiple access. Temporal sharing of channels includes approaches such as a time division multiple access. Here you can see the point to multi-point connection in the figure, that is host A to host B, host C and host D. One point host A to multi-point B, C and D. Advantages: easily deployed when compared to the deployment of point-to-point network because of the equipment must be deployed only at the new subscriber site. Disadvantages: all the remote must come within the visibility and range of base station. Yes. Then, according to based on physical topology, computer networks can have four broad categories, that is star, mesh, bus, and ring. Let us look into one by one. Here you can see the star connection where the central hub is connected one to one, like with host A, B, C, and D. Star topology: every host has a point to point link to a central controller or hub. The host cannot communicate with one another directly. They can only do so through the central hub. The hub acts as a network traffic exchange. For large scale systems, the hub essentially has to be powerful enough to handle all the simultaneous traffic flowing through it. Advantages: easy to troubleshoot, set up and modify. Only those nodes are affected that has failed. Other nodes still work. Fast performance with few nodes and very low network traffic. Addition, deletion, moving of the devices are very easy. Disadvantage: if the hub or concentrator fails, attached nodes are disabled. Cost of installation of star topology is costly. Heavy network traffic can sometimes slow the bus considerably. Performance depends on hub's capacity. A damaged cable or lack of proper termination may bring the network down. Now, the second type is mesh topology, where host A, B, C, and D are interconnected with each other one to one. In mesh topology, every host is connected to every other host using a dedicated link in a point to point manner. This implies that for n hosts in a mesh, there are total of n into n minus 1 by 2 dedicated full duplex link between the hosts. Data can be transmitted along various paths. Advantages: high redundancy and reliability. If one connection fails, data can still take another route. The security and privacy of the traffic, as the data is only seen by the intended recipients and not by all members of the networks. The reduced data load on the single host, as every host in this network takes care of its traffic load. Disadvantages: expensive and complex to set up and maintain due to large number of connection. Next is bus topology. All the devices share a common backbone cable to transmit data. Each device is connected to the single cable. A bus topology follows the point to multi-point connection. A backbone cable or bus serves as the primary traffic pathway between the hosts. The hosts are connected to the main bus using a drop line or tapes. Taps. Advantages: easy to set up and requires less cabling. The bus topology has a simple cabling procedure in which a single bus backbone cable can be used for an organization. Disadvantages: if the backbone cable fails, the entire network fails. Performance issues can arise as more devices are added. There is a restriction on the length of the bus and the number of hosts that can be simultaneously connected to the bus due to signal loss over extended bus. Here is the diagram of the bus topology where backbone bus is a single elongated line and the hosts are connected to that line by the help of taps and which terminates with a drop line. A ring topology: devices are connected in a circular manner where each device is connected to two others, forming a ring. Data travels in one or both directions around the ring. A ring topology works on the principle of point to point connection. Here, each host is configured to have a dedicated point to point connection with its two immediate neighboring hosts on either side of it through repeaters at each host. The repetition of this system forms a ring. The repeaters at each host capture the incoming signal intended for other hosts, regenerates the bit stream, and passes in on to the next repeater. Advantages: simple data transmission since data move in a specific direction. Fault identification and setup of the ring topology is quite simple and straightforward. Disadvantages: if any one net connection fails, the whole network can be disrupted unless the dual ring setup is used. Host A, host B, host C, everything are connected to a single repeater where the repeater are connected in such a way that one is connected to two neighboring repeaters in a ring, forming a ring structure. Network reachability: computer networks are divided into four broad categories based on network reachability: personal area network, local area network, wide area network, and metropolitan area network. Personal area network refer to a small localized network designed to connect devices within an individual's immediate proximity, typically within a range of a few meters. PANs are used for connecting devices like smartphones, tablets, laptops, and wearable technology to each other and sometimes to the internet. Key characteristics of PAN, that is Personal Area Network. Small coverage area. PAN typically covers a range of 10 meters, 30 to 33 feet, making them highly localized around a user. Wireless and wired. PANs can be either wireless WPAN or wired wireless Pan WPAN often uses Bluetooth, infrared, or Zigbee technologies for communication. Wired PAN may use cables such as USB or FireWire to connect device. Device interconnection PANs are primarily used for interconnecting personal devices like a smartphone to wireless headphones or a smartwatch to a laptop. Device interconnection is over, then the low power consumptions. Since bands are meant for short range communication, they are often designed to consume minimal power, ideal for battery operated device. Common technologies in PAN Bluetooth. A widely used technology in WPANs enabling wireless communication between devices like headsets, keyboards, smartphones. Infrared IR less common nowadays, but previously used for short range communication, especially in olden devices like remote controls. Near field communication, a technology that allows devices to communicate and they are in close proximity, often used for contactless payments. Example uses connecting a smartphone to wireless speaker via Bluetooth, syncing a fitness tracker with a smartphone app, using wireless mouse and a keyboard with a laptop. Local area network are the networks that connect devices within a limited geographical area, such as home, office, or school. A LAN is a collection of hosts linked to a single network through wired or wireless connections. LANs are restricted to buildings, organizations, or campuses. LANs are widely used for sharing resources like printers, files, and internet connections among multiple devices in a specific location. Key characteristics of LAN: limited coverage area. LANs typically a small area ranging from a single room to an entire building, usually within a range of a few hundred meters. High data transfer rates. LANs offer high speed data transfer with typical speeds ranging from 100 Mbps to 10 Gbps, depending on the technology used. Private ownership. LANs are generally owned, operated, and maintained by a single organization or individual, making them more manageable and secure. Wired and wireless. LANs can be established using physical cables or wirelessly through Wi Fi. Wired LAN uses Ethernet cables to connect devices to switches or routers. Wireless LAN, WLAN, uses the Wi Fi technology to connect devices without cables, offering more flexibility in device placements. Common technologies in LAN: Ethernet, the most widely used LAN technology, involving physical cables that connect devices to a central switch or router. Wi Fi WLAN. Wi Fi LAN technology that use radio waves to transmit data between devices and access point without the need of for physical connections. Components of LAN: switches and routers. Switches connect devices within the network, while routers help direct traffic between the LAN and external networks such as Ethernet. Network interface cards. Devices in LAN must have NIC to connect to the network either wirelessly or via an Ethernet cable. Cabling. Wired LANs use Ethernet cables, example Cat5e, Cat6, to establish a connection between devices and network equipment. Example uses connecting multiple computers in an office to a central server for file sharing. Creating a home network to share an internet connection, printers, and storage devices among multiple devices. Establishing a network in a school or university for students to access shared resources like the internet and file servers. Advantages of LAN. Resource sharing. Device can share files, printers, and other peripherals easily. Centralized data management. Data and applications can be centrally stored and accessed by users in the network. High speed LANs offer faster data transfer rates compared to wide area networks, WANs, enhancing performance of the local communication. Metropolitan area network are the networks that cover larger geographical area than local area networks but are smaller than wide area network. MANs connect various organizations or buildings within a given geographical network location or city. A MAN typically spans a city, town, or metropolitan area, connects multiple LANs within the area. MANs are commonly used to provide high speed network connectivity across large campuses, cities, or region where organization and institution need to share resources. Key characteristics of MAN. Geographical scope. MANs cover a broader area, usually between 5 and 50 kilometers, connecting multiple lines across a city or metropolitan region. High speed connectivity. MANs provide fast communication services, often using fiber optic cables to ensure high speed data transfer between different locations. Public or private ownership. MANs can be owned and operated by a single entity, such as a telecommunications provider, or by a consortium of organizations that need to interconnect their networks. Connects multiple LANs. A MAN links various local networks within a metropolitan area, allowing business, government office, schools, and other institutions to share resources and information effectively, efficiently. Common technologies in MAN. Fiber optic cables used for high speed data transmission over longer distances, commonly utilized in MANs for their speed and reliability. Ethernet. Metro and Ethernet services provide Ethernet connection over a large geographical area, allowing businesses to connect their LANs across cities. Wireless MAN technology. Some MANs use wireless connections such as microwave or WiMAX, worldwide interoperability for microwave access to extend network coverage where physical cabling is impractical. Example uses of MAN. City-wide internet connectivity. Many cities provide public internet services through MANs, offering high-speed internet access to businesses, schools, and residents. Interconnecting university campuses. University with multiple campuses spread across a city can use a MAN to connect their network, enabling seamless sharing of data, research, and administrative services. Government network. Local governments often use MANs to connect different departments, ensuring efficient communication and sharing of resources within the metropolitan area. Advantages of MAN. High speed data transfer. MANs offer high bandwidth and faster data transfer rates over large distances, making them ideal for connecting multiple LANs. Cost effective for organizations. Vans allow organizations to centralize resources like servers and data storage, reducing the need for duplication of infrastructure across multiple locations. Improved connectivity. Vans enable seamless communication and data sharing between institutions located within a city, enhancing operational efficiency, scalability. Vans can be expanded to cover larger areas or support more users as the need for connectivity grows. Example, a city may establish a man to provide high speed internet access to schools, library, hospitals, and government buildings. All of these which are located in different parts of the city but needs to be interconnected. Wide area network. WAN are the large scale networks that connects devices and smaller networks across broad geographical area such as cities, regions, countries, even globally. Unlike local area network or metropolitan area network, which cover more limited areas, WANs are used for connecting distant lands or mans over longer distances, enabling data exchange across multiple locations. Key characteristics of WAN. Geographic scope. WANs cover a vast area, potentially spanning entire countries or continents. The internet itself is a prime example of a WAN. Variety of transmission technologies. WANs use a range of technologies like fiber optics, satellite links, leased lines, and microwave transmission to connect different parts of the network. Public and private ownership. WANs can be either privately owned by company or organizations such as in corporate WANs or publicly accessible like the internet. Most WANs rely on the third party providers, telecommunications companies to lease bandwidth and infrastructure. Lower data transfer rates compared to LANs. While LANs offer very high speed data transfer, WAN speed may be slower due to the vast distances data must travel, although modern WANs are still capable of delivering high performance. Common technologies in WAN. Leased lines. Dedicated lines provided by telecommunication companies to ensure consistent, high quality connections between distant networks. MPLS, multi protocol label switching, a technique that directs data across a WAN through optimal paths, ensuring efficiency and quality of service. Satellite links use it for long distance communication, especially in remote areas where physical cabling is impractical. Fiber optic links used to transmit data over long distances at high speed. Fiber optics are a common choice for WANs. Components of WANs, routers, devices that route data between different LANs or MANs in a WAN. Routers are essential for directing traffic efficiently across the network. Transmission media. WAN uses a combination of physical media, fiber optic cables, copper wires, and wireless technologies, satellite microwave to transmit data. Gateways, devices that connect between different networks, particularly networks that use different protocols or architectures. Example uses of WAN. Corporate WANs, large corporations uses use WAN connect their offices in different cities of our countries, enabling employees to share files, use centralized applications, and communicate effectively. The internet, the largest one in the world, the internet connects millions of devices globally, enabling access to web resources, email, and other internet based resources, services. Banking network banks often use WANs to link their branches, ATMs, and data centers, allowing real time processing of transactions or and data storage sharing. Advantages of WAN: globally connectivity. WANs enable businesses, governments, and individuals to communicate and share data across vast distances, fostering global collaboration, centralized data management. WANs allow organizations to centralize their data storage, making it accessible from multiple locations while ensuring data security and backup. Scalability: WANs can grow as organizations expand geographically, allowing new locations to connect seamlessly to the existing network. Reliability: modern WANs often incorporate redundant connections and failover systems, ensuring continuous connectivity even if one part of the network fails. Disadvantages of WANs: high cost. WANs are most expensive to set up, maintain than LANs, especially when long distance infrastructures like leased lines or satellite links is required. Latency and speed. WANs, especially those covering large distances, may experience higher latency and slower speeds compared to LANs due to the distant data must travel. Security: because WANs span large areas and may involve public networks like the internet, they are more vulnerable or cyber attacks, requiring robust security measures. Example: a multinational corporation with offices in New York, London, and Tokyo can use a WAN to ensure that all its employees can access the same data resource and applications regardless of their physical locations. Layered network models. The interconnection, the intercommunication between hosts in any computer, maybe it a large area or a small scale one, is built upon the premises of various task specific layers. Two of the most commonly accepted and used traditional layered network models are the Open System Interconnection OSI, developed by the International Organization of Standardization ISO OSI reference model, and the Internet Protocol Suite. The Open System Interconnection OSI model describes 7 layers that computer systems use to communicate over a network. It was the first standard model for network communications adopted by all major computer and telecommunication companies in the early 1980s. The modern internet is not based on OSI but on simple TCP/IP model. However, the OSI 7 layer model is still widely used as it helps visualize and communicate how networks operate and helps isolate and troubleshoot networking problems. OSI was introduced in 1983 by representatives of the major computer and telecommunication companies and was adopted by ISO as an international standard in 1984. Basics of networking and emergence of IoT. Here, the diagram is clearly visible, which is showing the physical medium communication between the two OSM model. networked communication between two hosts following the OSI model, where host A and host B intermediate nodes. Here mainly consist of media layers and the host layer. That starts with physical layer, data link layer, network layer, transport layer, service layer, session layer, presentation and application layer. Now the intermediate node, which consists of only three layers, that is physical, data link and network. Another node for host B, even the host B consisting of the same seven layers, that is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Physical medium communication. Now let us know one by one. What is physical layer? This is the media layer and is also referred to as layer 1 of the OSI model. The physical layer is responsible for taking care of the electrical and mechanical operations of the host. Function deals with the physical connection between devices, including the transmission and reception of raw binary data over a physical medium. Physical layer is responsible for the physical cable and wireless connection between network nodes, and also responsible for transmission of the raw data, which is simply a series of zeros and ones, while taking care of bit rate control. These operations include or deal with the issues relating to signal generation, signal transfer, voltages, the layout of cables, physical port layout, line impedances, and signal loss. This layer is responsible for the topological layout of the network, star, mesh, bus, or ring. Communication mode: simplex, duplex, fully duplex, and bit rate control operations. Key components: cable, switches, network interface cards, NICs, and connectors. Protocols: Ethernet, IEEE 802.3, USB, DSL. Protocol data unit associated with this layer is referred to as a symbol or bits. Data link layer. This is a media layer and layer 2 of the OSI model. Function: responsible for error detection, correction, framing, and establishing terminating connections between directly connected nodes. Key components: switches, bridges, network interfaces, cards, NICs. Protocols: Ethernet, point-to-point protocol, PPP, and Wi-Fi, IEEE 802.11. This layer is composed of two parts: logical link control, which is LLC, identifies network protocols, performs error checking, and synchronizes frames. Media access control, which uses MAC address to connect devices and define permissions to permit and receive data. MAC, Media Access Control. LLC, Logical Link Control. A protocol data unit associated with this layer is referred to as a frame. Network layer. This layer is a media layer and layer 3 of the OSI model. It provides a means of routing data to various hosts connected to different networks through logical paths called virtual circuits. Function: manages the routing of data packets between devices across different networks, ensuring data is sent to the correct destination. Key components: routers and layer 3 switches. Protocols: Internet Protocol IP, Internet Control Message Protocol ICMP, Address Resolution Protocol ARP. These logical paths may pass through other intermediate hosts before reaching the actual destination host. The primary tasks of this layer include addressing sequencing of the packets, congestion control, error handling, and internet working. The protocol data unit associated with this layer is referred to as packet. Transport layer. This is layer of 4 of the OSI model and is a host layer. Function: ensures reliable data transfer, error recovery, and flow control between devices. It segments and reassembles data. Key components: gateways and firewalls. Protocols: transmission control protocol TCP, user datagram protocol UDP, and stream control transmission protocol SCTP. This layer is responsible for keeping track of acknowledgements during variable length data transfer between hosts. In case of loss of data or when no acknowledgement is received, the transport layer ensures that the particular erroneous data segment is resent to the receiving host. The protocol data unit associated with this layer is referred to as a segment or datagram. Session layer: this is the OSI model's layer 5 and is a host layer. Function: manages sessions between applications, establishing, maintaining, and terminating connections. It provides checkpointing and recovery of for long communication. Key components: APIs and session managers. Protocols: remote procedure call RPC, NetBIOS, and transport layer security TLS. The session layer sees full utilization during operations such as remote procedure calls and remote sessions. The protocol data unit associated with this layer is referred to as data. Presentation layer: this layer is a host layer and layer 6 of the OSI model. Function: translates data between the application layer and the network, handling data formatting, encryption, and compression. It ensures that the data is in a usable format. Key components: data converters, encoders, and decoders. Protocol: secure socket layer, SSL, JPG, MPG. The protocol data unit associated with this layer is referred to as data. Application layer: this is the layer 7 of the OSI model and is a host layer. Function: provides network services directly to end user applications. It facilitates user interaction with the network and includes protocols for various application services. Web browsers, email clients, and file transfer program. Protocols: hypertext transfer protocol HTTP, file transfer protocol FTP, simple mail transfer protocol SMTP, and domain name system DNS. Applications such as file transfer, FTP, file transfer protocol, emails, and other such operations are initiated from this layer. Application layer deals with the user authentication, protocol data unit associated with this layer is referred to as data. OSI model, TCP IP model. OSI, it stands for Open System Interconnection. TCP stands for Transmission Control Protocol. OSI model has been developed by ISO, International Standard Organization. This TCP is being developed by ARPANET, Advanced Research Project Agency Network. It is an independent standard and generic protocol used by as a communication gateway between the network and the end user. This TCP, it consists of standard protocols that leads to the development of an internet. It is a communication protocol and provides the connection among the hosts. In the OSI model, the transport layer provides a guarantee for the delivery of the packets. The transport layer does not provide the surety for delivery of the packets, but still we can say that it is a reliable model. This model is based on a vertical approach. This model is based on the horizontal approach. In this model, the session and the presentation layer are separated. In OSN model, both layers are different. In this TCP model, the session and the presentation layer are not different, but layers are included in the application layer. OSI model, known as the reference model through which various networks are built. For example, the TCP/IP model is built from the OSI model. It is also referred to as the guidance tool. TCP is an implemented model of an OSI model. In this model, the network layer provides both connection-oriented and connection-less service. In TCP/IP, the network layer provides only connection-less service. Protocols in the OSI model are hidden and can be easily replaced when the technology changes. In TCP, the protocol cannot be easily replaceable. OSI model consists of 7 layers, TCP consists of 4 layers. OSI model defines the service protocols and interfaces as well as provides a proper distinction between them. It is protocol independent. In the TCP model, services, protocols, and interfaces are not properly separated. It is protocol dependent. The usage of this model is very low. This model is highly used. OSI provides standardization to the device like router, motherboard, switches, and other hardware devices. TCP does not provide the standardization to the devices, it provides a connection between various computers. Internet Protocol Set, TCP/IP Protocol Set. Internet Protocol Set is yet another theoretical framework that provides a level of abstraction for comfort of understanding and development of the communication and network system on the internet. However, the Internet Protocol Set provides only 4 levels of abstraction: link layer, internet layer, transport layer, application layer. Host A to host B, only 4 layers, that is physical layer, data link layer, transport layer, application layer. Then the intermediate having link and internet. Host B, physical data link, transport, application. Networked communication between two hosts following the TCP/IP suite. Link layer. The first and base layer of the TCP/IP protocol suite is also known as the network interface layer. Link layer. This layer is identical with the collective physical and data link layer of the OSI model. The main job of the link layer is to enable the actual transmission of packets across physical connections, whether through wired or wireless mediums. This layer is designed to work independently of the type of physical medium being used, like copper wires, fiber optics, or radio waves. It can also adapt to different network access methods and frame formats, making it multi-purpose enough to work with technologies like Ethernet, wireless LAN, and ATM. Asynchronous transfer mode. Internet layer, layer 2 of the TCP/IP protocol set is somewhat identical to the network layer of the OSI model. It is responsible for addressing address translation, data packaging, data assembly, and disassembly, assembly, routing, and packet level tracking operations. Some core protocols associated with this layer are Address Resolution Protocol (ARP), Internet Protocol IP, Internet Control Message Protocol (ICMP), Internet Group Management Protocol (IGMP). Traditionally, this layer was built upon IPv4, which is gradually shifting to IPv6, enabling the accommodation of much more significant number of addressing and security measures. Transport layer, layer 3 of the TCP/IP protocol suite is functionally identical with the Transport layer of the SI model. This layer is tasked with the functions. Error control ensures that data is delivered accurately and without errors by detecting and potentially correcting errors that occur during transmission. Flow control manages the rate of data transmission between sender and receiver, ensuring that a fast sender doesn't overcome a slower receiver. Congestion control helps avoid network congestion by controlling data flow and adjusting transmission rates when the network becomes too congested. Splits large messages into smaller segments for easily transmission. Each segment is sent independently and reassembled at the destination. Uses port numbers to differentiate multiple communication sessions between the same hosts. Transmission Control Protocol TCP and User Datagram Protocol UDP are the core protocols upon which this layer is built, which in turn enables it to have the choice of providing connection oriented or connection-less services between two or more hosts or networked devices. Transmission Control Protocol TCP type connection oriented purpose ensure reliable, ordered, and error check delivery of the stream of data between applications. Key features: connection establishment, use a three-way handshake to set up a connection. Reliable transmission ensures all data reaches the destination correctly. Retransmits lost segments of if necessary. Flow control adjusts the sender's rate to avoid overwhelming the receiver. Congestion control prevents too much data from being sent into the network during congestion. Segmentation and reassembly breaks data into smaller segments and reassembles them at the destination. Use cases: web browsing, HTTP, HTTPS, email, SMTP, IMAP, POP3, file transfer, FTP, etc. User Datagram Protocol UDP. Type connectionless purpose provides faster but less reliable data transmission, no guarantee of data delivery or error correction. Key features: no connection setup, does not establish connection before sending data, best for delivery, sends data without checking if it arrives at the destination. Lower overhead, faster than TCP due to the lack of error checking mechanism. No flow or congestion control leaves it the application to manage these. Use cases: real-time applications like video streaming, VoIP, online gaming, DNS queries. Streamline Control Transmission Protocol (SCTP). Type connection oriented purpose combines features of TCP, UDP, and all, providing reliability. Connection oriented data transmission while supporting message oriented traffic. Key features: multi streaming, allows multiple independent streams within a connection to prevent head of line blocking. Multi homing supports multiple IP addresses for fault tolerance. Reliability ensures delivery with error detection and retransmission. Use cases: telecommunication, signaling, and other critical applications requiring reliability and redundancy. Datagram Congestion Control Protocol DCCP. Connection oriented type purpose provides congestion control mechanism for unreliable data transmission. It's designed for applications that prefer timeline over reliable delivery but need congestion control. Key features: congestion control supports congestion control similar to TCP. Unreliable delivery like UDP. It does not guarantee the delivery of data. Use cases: multimedia streaming, online games, real-time application where delay is more important than complete reliability. These protocols enables the transport layer to offer both reliable TCP, HTTP, and unreliable UDP DCCP communication, ensuring applications can choose the right balance between speed, reliability, and the complexity. Application layer. The functionalities of the application layer, layer 4 of the TCP IP protocol set are equal to with the collective functionalities of OSI model, session and presentation and application layer. This layer enables an end user to access the services of the underlying layers and defines the protocols for the transfer of data. Hypertext Transfer Protocol HTTP, File Transfer Protocol FTP, Simple Mail Transfer Protocol SMTP, Domain Name System DNS, Routing Information Protocol RIP, and Simple Network Management Protocol SNMP are some of the core protocols associated with this layer. Thank you for watching. Do like, share, and subscribe to my channel.